just simply say that OM and ON are not parallel. So in short, what I'm going to say is that NB for two vectors to be parallel, you must write both in form of OA is equals to X OB. So you must always write this one up with a scalar for two vectors to be parallel. So in this case, you see, we had 5 1 in the bracket, but in the bracket we have 2 1. So in this case, this one should not be parallel. Okay, so that means application of parallel vectors in mathematics is always set by through discussion of something called collinear points. Something called collinear points. So we're going to discuss collinear points before we move to midpoints. So let's discuss about collinear points. Collinear points. So in maths, 2 points are seen in collinear if they fulfill these 2 conditions. Two points are seen to be collinear if they fulfill these 2 conditions. The first condition is this one here. Number 1, if they are parallel to each other. And 2, if they have a common point. So when we say that 2 points are collinear, we say that 2 points are collinear first if they are parallel to each other and if they have a common point. So in the previous examples, we have been trying to prove how to show that 2 points are parallel to each other. So first of all, we'll consider this one here. OA, point OA is point OA. So we'll say a point M, 2, 4, and a point B, and a point B, 6, 12 are on the same line. We are calling R on the same line. Show that M and N are collinear. So this is the only example I'm going to consider collinear point. So we say that 2 points are collinear first if they are parallel. So I'll try to prove that points 2 and 4. I'll try to show that M and N are collinear. So what I'll do, they are on the same line. So to show that they are parallel first, I'll try to see if they are on the same line. So I'll get M. I'll try to get okay, for collinear points, we always consider, let's say, more than 3 points. So I'll take this other point again. I'll try to get vector OM. So vector OM will be what? With respect to origin, which is 0. So vector OM will be M minus origin. What is M? 2, 4. And what is origin? 0, 0. So I'll get it as what? 2 minus 0 is 2. 4 minus 0 is 4. So that is my vector OM. Again, I'll try to take origin with respect to N. So I'll get vector ON. Or someone else can decide to get MN. But me, I want to get ON. So ON and get ON and take a point like 6, 12 minus 2, 4 minus 0, 0. So I'll get this point as what? 6, 12. Then I'll try to get a common factor that goes in these two. as I say, for you to show that two points are parallel to each other, then what you do, you take the one with the bigger figures. So if this one is 6, 12, then you look for a common factor. So we have 6, 12. What is common? 3. So it will go 3 will go there, 3, 2, 4. And then you see that this one here is similar to this one. So that shows that O so what am I going to prove there? I'll prove this one here. But now point ON is equal to 3 what? ON. So after I've shown this one, then this means that ON, point N, is parallel to what? N. The only thing is remaining that how because they are in a common point. They are in a common point because they share this common point here, origin O. So I write M and N are, so my final conclusion will be M and N are collinear because they are parallel. They are parallel because we have done what? We have done a proof, and this is the proof. They are parallel to each other and has a common point S O. We are going to do example 2. Example 2. A point M, let's say a point A, 3, 1, a point B, 5, 2, and a point C, 7, 3, are on the same line. Prove if A, B, C are collinear. So here I want to test if point A, B, and C are collinear. So what I do is this. I try to get vector AB. Vector AB will be what? B minus A. So what is B? 5, 2. And what is A? 3, 1. So what I'm trying to do is, I'm trying to prove that B and A are parallel to each other. So what that means 5 minus A is 2. 2 minus 1 is 1. And then again I get vector BC. I can now get vector BC. BC will be what? BC will be C minus B. Which will be 7, 3 minus 5, 2. So I'll get 7 minus 5 is 2. 3 minus 2 is 1. So we have seen that this is 2, 1, and this 2, 1. So this means that I can get a common factor here. What is a common factor? What number goes with 2 and 1 is 1. So I'll say BC will be 1, 2, 1. So this means that I can write that AB is equal to 1 BC. So the moment I've written this way, this means that A, B, and BC are what? Parallel to each other. So the remaining thing to prove is that if A, B are parallel, then it means what is the common point? The common point is B. B is this other side of this side. So I'll say point A, B, C are collinear because AB is parallel to BC and B as a common point. So up to that case, we have discussed all the maths involving what? Involving parallel vectors. So we move next to midpoint of a vector. Midpoint of a vector. Midpoint of a vector. midpoint, midpoint of a vector. So, in midpoint of a vector, midpoint is just the midline of a vector. So, example, we just do example and then we dash example. A point N, is the midpoint of vector A 3, 2, and vector B, vector B, vector B, vector B 5, vector 2. Determine the coordinates of N. So if N is the midpoint and you determine the coordinates of N, so what you do is this. You remember the concept of midpoint in equation of a set line. So you just take this one, this plus this is divided by 2. So N